So I asked someone what the hardest question on the packets were, and they said it was question 12, 13, 15, 19, 21, 22, 23, 26. So I'll go through every single one of those and how you solve them, and hopefully you find this video helpful. So starting on question 12, it's blatantly asking you your knowledge on the absolute values. And so first of all, we need to understand absolute values as a general concept. Here we see that it says, let's take, for example, y equals absolute value of x. And so how absolute values work is that when the value inside the absolute value is positive, then you can just remove the absolute value sign. When it is negative, it would just be the negative version of what is inside. So it's the equivalent of a piecewise function on the positive and negative domains. So what that means in simpler terms is that, look, when x is greater than 0 or equal to 0, your function is y equals x. Because in the absolute value, when x is greater than 0, this inside value is positive. However, when the inside value is negative, so x is less than or equal to 0, you get y equals negative x, and thus being your function here. So first of all, what that means is when you have the absolute value function and you are negative, you have to take the negative value of what is on the inside. So again, when x is negative, y is now the function negative x. This is the piecewise function that defines the absolute value here. So what that means in context of this equation is we know that, look, since we're approaching 0 from the left side or the negative side, this absolute value doesn't equal 1 over x. The absolute value sign goes away and it becomes 1 over negative x. So your function now therefore is 1 over x minus 1 over negative x. So again, because the inside is negative, we don't have x, we have negative x. So this is minus a negative, it becomes therefore positive, so you're left with 1 over x plus 1 over x, and you're left with 2 over x. And since you're finding the limit, it's this limit as x approaches 0 from the negative side of 2 over x. That just becomes 2 over like negative 0. You have to imagine it as negative 0. It's some 2 value divided by a very, very, very small negative value. And so the 0 goes into 2 a negative infinity amount of times. Like, yes, I understand there's no such thing as negative 0, but you have to think about it that way because as it approaches 0 from the negative side or the left side, all the values are negative. So you would get negative infinity as opposed to infinity. 13, again, tests you on the concept of, do you know what something divided by 0 is? So as a general rule, we say that if you have some number like 5 divided by 0, it becomes an asymptote or it becomes infinity. Because the question is asking, how many times does 0 go into 5? The answer is infinity amount of times. So here we can just plug in 9 every time we see x. We get square root 9 over 9 minus 9. Y'all might be like, oh, well, the bottom's 0, so we're screwed. But the answer is no, that's fine, because you're still at 3 over 0. Anything divided by 0 is infinity, so your answer is infinity. Get out of here. And then on question 15, you have to be able to know how to go in and out of square root numbers, as well as how you divide and solve for limits that go to infinity. So the general rule is you find the biggest polynomial, or the biggest power of x, and you divide the top and the bottom by that value. So for example, if you had x cubed over x squared, you divide everything, the top and the bottom, by x cubed. So the top divided by x cubed is 1. The bottom divided by x cubed is 1 over x after you simplify it, and that would be how you solve it. So here we see that the biggest value is square root of x squared. So how do we get something out of the square root? The answer is you just multiply the top and the bottom by 1 over x, and you bring 1 over x into the square root. So it would be, so dividing is the same as multiplying by 1 over. So it would be 1 over x times 3x squared minus 1 divided by 1 over x times the bottom, which is x minus 1. So the bottom is pretty simple because you can just FOIL it and then you get your answer. So you get x over x is 1, negative 1 over x is just minus 1 over x. And here, the 1 over x is not, you can't put it into the square root directly, but you can transform it into 1 over x squared. Square root of 1 over x squared times 3 over x squared minus 2. So once again, you can put it into the square root by squaring it, and then adding a square root, because these two are equivalent statements. Next, you can multiply each one by square root x and essentially FOIL this one, FOIL it as well. So 3 times x squared over x squared is 3, minus 2 times 1 over x squared is just minus 2 over x squared. This goes to square root over 1 minus 1 over x. Now we need to take the limit as this heads to infinity. And so another rule we need to remember is just like when you divide everything by 0, it goes to infinity. Every time you divide something by infinity, it goes to 0. But particularly with Miss Harris, I don't know if it's true for other teachers, but you can't just plug in infinity because that doesn't make sense. You just have to write a little arrow here is, look, 2 over infinity squared heads to 0 is how you write it. 1 over x heads to 0. Like, they take points off if you don't write it and you like plug in infinity directly. You can't do that. So this goes to 0, this goes to 0, and you're left with 3 minus 0, which is just square root 3, over 1. So your answer is square root 3. For 19, it is testing your ability to do the conjugate thing where you multiply by the opposite. So you can first probably guess that that's what they want, because this is plus 3, this is minus 3, and so it'll cancel out eventually. So what you do is you multiply by the top and the bottom by square root 5x plus 3 plus square root 3 over square root 5x plus 3 plus square root 3. So remember, if we have some value a plus b multiplied by a minus b, then that equals a squared minus b squared. This is a rule you need to remember. So essentially, the a in this case is this entire square root 5x plus 3. The b in this case is square root 3. So every time you see a, you get this value. Every time you see b, you make this value. And we see that, yes, this holds true. This is a minus b. This is a plus b. Therefore, it can be rewritten as a squared minus b squared. So that's just 5x plus 3, because this first one's squared, minus the second one squared, which is 3. Divided by the bottom, which is x, times the entire thing, which is square root 5x plus 3 plus square root 3. And make sure you rewrite the limit sign. So the 3's cancel out, and you're left with just 5x on top. And the whole purpose of doing this is so you can cancel out your x's. So 5, there's x on the top, there's an x on the bottom, so it's multiplied by x, divided by x, cancel out. And you're left with 5 divided by square root 5x plus 3 plus square root 3 as the limit as x approaches 0. So 0 gets plugged into every time you see x, so this just heads to 0. So you're left with 5 divided by square root 3 plus square root 3. And thus 5 divided by 2 square root 3 should be your final answer. Now on to 21. So again, this is the exact same question as earlier, so I'll go through it a bit faster. But we just know that we need to get the x squared and the x, and we divide everything by 1 over x. So, or multiply it by 1 over x divided by 1 over x. So multiply the top by 1 over x, multiply the bottom by 1 over x. This goes into the square root, so it's the same as saying multiplying it by, so 1 over x equals the same thing as square root 1 over x squared. That's a rule you just need to know. Then you can essentially FOIL the bottom, FOIL the top, and so you FOIL the bottom and you're left with 3 times x divided by x. I'll write it out. So this is 2x squared divided by x squared plus 1 over x squared, because this goes here. This is essentially square root, because it's all in the square root, divided by 3 over x, 3 times x over x times 5 over x. And so now when you simplify it, the x cancels out. You get 2 plus 1 over x squared divided by, this is just 3, this is minus 5 over x. Then remember, when you take the limit as this heads towards negative infinity, we recognize that, again, 1 divided by negative infinity is still going to be 0. So once we plug in infinity from here, the whole thing becomes 0 because it's 5 divided by an infinitely large number. And so it would go in 0 times. So this just heads to 0. This heads to 0. And you're left with 2 over 3 as your final answer for 21. Then for 22, it tests you on the same thing. So remember, the first step in the process is identifying which is the largest polynomial. The answer is squared. So you multiply everything by 1 over x squared. Divide by 1 over x squared, the top and the bottom. And so this goes on the top. You can just multiply. It's essentially, again, it's a FOIL equation. You just go multiply the first one, you're left with 1. Multiply the second one, you're left with x over x squared, which then equals 1 plus 1 over x. Now the bottom is the same thing. You FOIL it. So this is 3 over x squared. This is minus x over x squared. This simplifies into 1 plus 1 over x divided by 3 over x squared minus 1 over x squared. So as this approaches 0, we see that when this limit as x approaches infinity on this question, this goes to 0, this goes to 0, this goes to 0. Now you're left with 1 over 0. So just remember what we were talking about earlier is that as long as you have a number on top and 0 is on the bottom, the answer always goes to infinity because 0 goes into 1 an infinite number of times, and that will be your final answer. On question 23, again, it is testing your ability to use the conjugate. So you just multiply it by 1 plus root x over 1 plus root x. I don't think it matters if you choose plus or minus, but that's something. Actually, what you can do here is you divide everything by square root x. So it would just be times 1 over square root x over 1 over square root x. So the first one goes to just, since you're multiplying, again, it's essentially like FOILing. So the first one would just be 1 over square root x. This divides out to 1 because it's multiplied by 1 over square root x, so it all goes to 1, minus 1. The bottom is 1 over square root x plus 1. Now again, you can take the limit as x approaches infinity. Since this is still on the x is still on the bottom, this is just 1 divided by square root infinity. It would still go to 0. This bottom still has the 0, so you're left with negative 1 over 1, and your final answer would be negative 1. Now the final question is number 26. So you can probably, we would say that the way to solve this question is by solving it using the conjugate. So you just multiply the top and the bottom, or you would multiply the top and the bottom by the opposite of this. So it would be square root x plus 2 plus square root x over. So you multiply it by this. So this is the exact same top except for its opposite. So you can usually know when to do either one is if one, they have a lot of related terms on the top and bottom. For example, there's a 2 here, there's an x here, there's a 2 here, there's a 2x here. They're probably related. Second of all is if the top has a square root and the bottom doesn't, then you probably want to multiply it by the conjugate instead of doing the other technique of dividing by the highest polynomial. So we know that a squared plus b squared, a plus b times a minus b is a squared minus b squared. So this is, we can square the first one, which is x plus 2 minus 2x over, this just becomes x squared minus 2x times the bottom. So the first thing you want to make sure is you don't want to simplify, because if you simplify, then you miss a lot of the little divisions that you could do here or there. So you want to keep it in this form. Then we've simplify the top. This is x, this is minus 2x, so you're left with negative x plus 2 over x squared minus 2x square root x plus 2 plus root 2x. Then we see that x plus 2 looks pretty eerily similar to here, so we might want to factor out another x from the bottom so that it becomes x minus 2 times x times square root x plus square root x plus 2 plus square root 2x. The top becomes minus x plus 2. Okay, so you'll factor out an x from here, and it went here. Now what we want to do is, we see that these two are literally the same, except for they are opposites. So you can multiply the top and the bottom by a -1 and a -1. So what I think about it this way is one of them actually you apply to the top or the bottom, and the other is you just hold it at bay. So what that means is like you multiply the whole entire top by -1, and you're left with x plus 2. Sorry, you're left with x minus 2. The bottom also has an x minus 2 times x times square root x plus 2 plus square root 2x. And the bottom also has a -1 because we didn't multiply this through. We see that x minus 2, x to the plus 2 on the top, they cancel out. So you're just left with 1 over x times square root x plus 2 plus square root 2x times -1. Now we just plug in 2 as the limit. I don't have room anymore to write the limit sign, but every time you see x, you plug in 2, and your final answer should be 1. This is 2 times square root 4, which is 2. This is square root 4, which is 2. So 2 times 4 times -1. Your answer should be over -8. So -1/8 should be your final answer.